Hello class, it's Mr. Kablan again, and here today to present the third lesson in chapter 5, dealing with slope. And before I begin, I just want to quickly go over some of the stuff that we've already looked at in the first two lessons for this chapter. And I just want to specifically point out the two formulas that you should have committed to memory, and just to draw also some conclusions based on the last two lessons we looked at. Now, as you can see over here, I have two formulas on the screen. I have y equals kx and y equals mx plus b. Now remember from 5.1, y equals kx was the formula for direct variation. So when you're looking at any line which does not, which passes through the point 0, 0, okay, it will always have an equation of y equals kx. So that would be direct variation. Now the one right below it, the y equals mx plus b, okay, this here, remember, was an example of partial variation. Now, when you are looking at a graph of partial variation, remember how this one was different from direct variation, was that graphs that are of partial variation did not pass through the point 0, 0. And this letter B here represented the initial value, or where the line passed through or started on the y-axis. So I just want to draw the differences between the two formulas or two equations that you see on the screen. Now, the reason why I have them above and below each other is because when I line them up like so, okay, you'll probably notice that they have a couple of things that they do have in common. And the first thing that they have in common, if you take a look at the letters, obviously is the letter Y. Okay, so let's establish that. Okay, and you notice they also have a letter X. So for both formulas, you notice both Y and X are there. Now, another similarity they have them, believe it or not, is this other letter here, which is the K and the M. Now you're probably wondering, well, what is the difference between the K and the M? Well, simply, it's just the letters. When you're looking at K and M, remember in the first lesson for direct variation, K represented what was called the constant of variation, which we reviewed as the same thing as the calculation of rate. Now, K and M, believe it or not, is basically the same thing. And what we're going to see for today is we're going to look at uh, the calculation of slope, okay, which is represented by the letter M. And we're going to see that the letter M actually is going to be called a couple of different things in this particular chapter. So I just want to introduce that to you so you can see what you have here are two formulas which are very, very identical. All right, so in today's lesson, like I said, we're going to go over the concept of slope. And believe it or not, I did mention this briefly when we were looking at the lesson in chapter 2 dealing with motion. Okay, and I just mentioned it briefly because I said in that particular lesson, well, we're going to learn in chapter 5. Well, guess what? We're in chapter 5 and we're going to learn about slope today. Now, what slope refers to in general is the steepness of a line. And the way you calculate that, as you can see in the diagram, is using the first slope formula you're going to learn in this chapter, which is going to be rise over run. Now, if you take a look at the diagram in the top right-hand corner, okay, what rise refers to is the distance going up and down, okay, and the run refers to the fact you are looking at the distance going from left to right based on the drawing of what's called a rate triangle. Now, the rate triangle itself is the triangle that you can, it's a right angle triangle that you can draw either below or above the line. And the purpose of the rate triangle is simply just to determine the rise and the run simply for today's lesson for the time being by counting the number of spaces between 2 points, okay, which you were also introduced to in a previous chapter. Now, the two general directions for the slopes of lines for today, okay, is positive and negative. So for the first one here, it says a line segment going up from left to right will have what's called a positive slope. So a line that goes like this, okay, is an example of a positive slope. And that goes for any line that's going up from left to right. Now, the opposite of positive is, well, you guessed it, is negative. So any line that is falling down to the right, okay, will be a negative slope. Now, what we're going to go through today are a couple of things here is first of all, learning how to use the formula for the slope of the line using rise and run. Okay, and I'll mention briefly in terms of when you can use rise over run to calculate slope, because as I mentioned earlier in this chapter, you'll actually be learning different ways to calculate slope. All right, let's take a look at some numbers here. And if you have a calculator in front of you, just refer to the key that we've been using quite a few times in this course, the fraction key. And you can actually use that to calculate slope as well, where you can take a number and then reduce it into lowest terms. So when we're calculating slope, as you can see on the bottom left and the bottom right hand corner are just reminders in terms of what constitutes a positive slope and what constitutes a negative slope. All right, so for each one here, what we want to do here is to calculate the slope or steepness of this line here. Now, step number one, anytime you're looking at the calculation of the slope of a line, okay, always draw a right triangle. Now, as I mentioned before, a right triangle is a right-angled triangle which you can draw above or below the line that's given. And in this example, I'm going to draw this under the line. Now, what we're going to do here using the formula rise over run is to count the number of spaces between the points and where it ends. Okay, so if you take a look at the cursor over here, I'm going to start at the top right-hand corner over here. So I'm going to start counting from that spot over there. Now, the reason why we're doing that is because from here, we're going to calculate the rise. So from this point over here, I have 1, 2, 3, 4, 5, and 6. So the rise for this line is going to be 6. All right. Now, for the next one, we're now going to calculate the run. So to calculate the run over here, I'm going to start from this point, and then I'm going to count to the right. So if you take a look at this point over here, we have 1, 2, 3 spaces. So what we have now is a rise of 6 and a run of 3. Now, before we actually did this, another checkpoint that you should do here is to look at the direction of the line. Just remind yourself that since this is a line that's going up to the right, what we have here is a positive slope. And as you can see, we have that with this step over here. Now, if you take a look at this fraction over here, notice what we have here is an example of an improper fraction. So you can do one of two things. You can either go 6 divided by 3, or you can use the fraction key and put 6 fraction key 3, and that will reduce itself to 2. Now, please make sure that when you're looking at the slope of the line that you always express your answers. Number 1, if it's a whole number, keep it as a whole number. Okay, or number 2, keep it as a fraction in lowest terms. And we're going to see a couple of examples of that throughout this chapter as well. All right, so let's take a look at another example. And the only difference with this one, okay, compared to this one over here, is the direction. So when you take a look at a line, always ask yourself again, what do we know about the direction of the slope of this line? Well, since this line is going down to the right, from left to right, okay, what we're going to have here as our final answer will be a negative slope. So step number 1 here, draw a right triangle, or sorry, a right triangle underneath the line here, and we're going to do the exact same thing and count the number of spaces. So from the top left-hand point, we have 1, 2, 3, 4, 5 spots. Okay, and then when we count the run over here, starting from the right point, we have 1, 2, 3, 4. Now, when we express our answer here, you'll notice that what we have here will be another example of an improper fraction. Now, if you accidentally put in -5 and you divide it by 4 and you get a decimal, okay, don't forget you can switch that back by pressing the fraction key again to put it back into a fraction into reduced terms. Now, when we're looking at slopes of lines, always express your answers as either a whole number, or in this case here as an improper fraction in lowest terms. Okay, whatever you do, unless you're instructed otherwise, do not express your answer as a decimal. Now, also just as a reminder, notice that in this question compared to the other one, we have a negative sign that's in front of the slope. Now, notice I have 2 answers here, and just to show you the difference, the fact that this one here is in the middle and this one here is in the top. They're exactly the same thing. Okay, when in doubt, just take the negative and place it to the numerator or the top number just to avoid any type of complications there. Now you're going to see that if you move the negative to the numerator or the top number, it's actually going to help you when you're drawing these lines in just a moment here. All right. Okay. Now I have a big finger there just as a reminder that anytime you have a line that's falling down to the right, you will always have a negative slope. So that's just another friendly reminder. All right. And there's another friendly reminder right there, inwards. Okay, so just make sure you remember that anytime you see a line that's falling down the right, you're always going to have a negative slope. All right, so we've seen two examples so far dealing with the two basic cases or the two common cases. We have a positive slope and the negative slope. So now we're going to look at special cases. And these are special cases because these, anytime you see these next two lines that we're about to look at, the answer will always be the same. So what you see here is a horizontal line, okay, going from left to right. We're going to approach this the exact same way the previous question. The only difference in this case is that we're going to see something about all horizontal lines. So step number one, we have rise over run. Now, in the last two examples, we drew a right triangle, but as you can see, we can't do that for this line because we have a line that's going straight across. However, if a line does not go up or down, okay, what we really have there is a rise of 0. And the reason why it's a rise of 0 because it doesn't go up or down. All right, and what we have here, we're just going to calculate the run over here, which is the distance between these 2 points. So from the left over here, from this left point, I'm going to count 1, 2, 3, 4, 5, and 6. So you have a run of 6. Now I'm going to put that as rise over run of 0 over 6. And if you put that in your calculator, you will get a slope of 0. Now, the next thing I just need to point out here is, do we need to do all these steps for horizontal lines? Okay, and the answer is, well, you could if you want to, but it's not necessary. And the reason for that is the fact that all horizontal lines will have a slope of 0. So it doesn't matter if your line is this big or this small, okay? You're always going, all horizontal lines will always have a slope of 0. There are no exceptions to that. Right? So that's one of our, quote, special lines. All right, our next special line one here, the opposite of horizontal, is a vertical line. Okay, and this one over here is going to be is interesting. All right, so what we have here is a vertical line, which is a line that goes straight up and down. And again, we're going to approach it with the exact same way over here. And you probably want to have a calculator for this one because you're going to see something that's a little bit different, and it's going to be something that you've never seen before. So if you have a calculator, okay, feel free to use one on your cell phone if you want. And let's see what we do with this one. So in this one over here, we're going to do a rise. As you can see, it is going up and down. So we're going to do that. And we have a rise here. And just to count, we have 1, 2, 3, 4, 5, 6, 7, 8. And you notice that since this line does not go left or right in any spaces, what we have here is a run of 0. All right. Now, what I want you to do right now in your calculator is to put in 8 and divide it by 0 and press equals. Do it yet? Now, if you're looking at your calculator and you have the same ones that I have in class, you'll probably get an error message or something that tells you that you did something wrong. If you did, guess what? You actually did something right. And the reason for that is because when you take a number and you divide it by 0, you have what's called an undefined slope, okay, or an undefined number. And the reason for that is because you cannot divide any number by 0. All right, so to summarize all that, going back in a similar fashion to the horizontal lines, do we need to do all those steps for a vertical line? And the answer to that is no, because it doesn't matter how long or how short a vertical line is, it will always have what's called an undefined slope. Now, please, whatever you do, please keep it as an undefined slope, okay? It is not the same thing as 0, because remember, 0 is a slope of horizontal lines or lines going from left to right, okay? Undefined is the only answer for this particular line here. So just make sure you commit that to memory, okay? And believe it or not, of all the slopes that you're going to deal with, this is the only one that does not involve a number, okay? It actually involves a word. So just make sure you remember that particular word. All right, let's take a look at more examples over here. And this time over here, we're going to look at 3 ski hills, and we're going to approach it the exact same way. And this is another exercise that I'm going to show you that you can, when you have your calculator, especially ones that we use in class over here, how we can go from one form to the other. So what we're going to do here is we're going to calculate the slope of each of these hills here simply by using rise over run. So that's no different. All right, so if you take a look at the rise over run over here, and we already have our rate triangles given to us. Remember, the rise is the distance going up and down over here. So the rise here is 60, and the run here would be 70. So what we have here will be 60 over 70 as a rise over run. Now, just as another reminder that all of your slopes must be represented in lowest terms. So once you take this 60 and you press your fraction key and put it over 70 and press equals, okay, you will get a fraction of 6 over 7, which is a fraction in lowest terms. Okay, same thing with this next one. Okay, we have again, use a rise over run. And before we proceed to the next example, actually, if you take a look at the 6 over 7, what we're going to do first here is we're going to change it to a decimal. So if you haven't cleared it, don't clear it just yet. Otherwise, what you can do in the next example here is just take 6 and then divide it by 7. And the reason I'm having you do that in this particular example is because it's going to help us answer this last part of the question over here. And you should get 0.86. All right. So we're going to do that for each of these examples to help us answer this last question here. So for this next one here, again, we're going to do rise over run. Okay, the rise here is going to be the 60. The run here is going to be the 110. And again, using the fraction key, you express that in the lowest terms here, which gives us a fraction of 6 over 11. Now, again, if you have the fraction in your calculator, leave it as it is, okay, and press the fraction key, or you could take 6 and divide it by 11. Either way, you will get a decimal here of 0.55, roughly. All right, I'm just rounding everything to 2 decimal places for simplicity. All right, and this last one over here, we have, again, a rise of 80, a run of 100, which gives me 80 over 100. And when we put that into reduced terms over here, it'll give us a fraction of 4 over 5. And when we change it to a decimal, you're going to see that's going to give us 0.8. Now, to answer the final part of the question over here, to determine which hill is the steepest, okay, you just have to take a look at the decimals over here and see which one is the highest. Okay, and in this case over here, it's going to be hill A. All right. So again, this common question that people ask, when do we know to keep it as a fraction in lowest terms, and when do we know to keep it as a decimal? Okay, unless you're stated otherwise, always keep your fraction in lowest terms. Okay, in a question like this, it does help to have it as decimal simply because you can see exactly what the numbers are once you convert the fractions into decimals. All right, let's proceed to the next example over here. So we're going to do the exact same thing again. I just want you to get used to how to calculate the slope of any line over here. So for this one over here, okay, what we have here is a ramp that is going up to the right. And it says here the ramp at the local gymnasium rises 2.75 meters over a run of 5 meters. So again, the triangle's drawn for us. We just need to put the numbers in the formula, rise over a run. Okay, so what we have here is a rise of 2.75 and a run of 5. And we have this. Now, again, going back to the question, when to express it as a decimal and when to express it as a fraction. In this question here, you notice that the numbers given to you in the question are decimals. Okay, if you your final answer, it would be appropriate to express your final answer as a decimal for these type of questions if the numbers in the question are given to you as a decimal. So when you take the 2.75 divided by 5, you will get a slope here of 0.55. Now for part B, to explain what slope means in this situation, okay, this basically determines how steep this particular ramp is. And the way to explain that is that this number of 0.55, it's telling us that this ramp has a rise of 0.55 for every 1 meter going across there. All right, so that's just going to just be a quick thing. I just want to quickly go over there. All right. All right, so now that you've seen many calculations for slope, you notice we're just doing the exact same thing over and over again, just looking at different contexts of the questions over here. All right, so this next one. Remember, I believe this is in the second example in this lesson over here, when we're expressing fractions in lowest terms, and I asked you to put the negative on the numerator of the top number. You're going to see that it's going to help you for these type of questions where you have to use the slope in order for you to plot another point. All right, so remember when you have a slope of a slope of a line, okay, you have two numbers. The top number is the rise and the bottom number is the run. So it says here, a line segment has one endpoint given the coordinates 2 and 8. And all we know about this line here is the slope of this particular line is -4/3. Now you notice for this example, I put the negative on the numerator because you're going to see how it's going to be applied for this particular example. So it says, using the slope, find the coordinates of another possible endpoint B. And the way we're going to do this is to use a graph and then follow the next set of instructions that I'm about to put up here. All right. So step number one, what we want to do is to plot the point that's given to us in this question. So what we have here is a point of 2, 8. So that's going to be this point over here. As you can see, all I did there was go right 2 and then up 8. Okay, and let's label that just for reference there. Now, before we proceed with the next step over here, we should picture in our mind what in the world this line will look like. Well, we learned from the second example today, okay, is that any time that you see a negative slope, you'll always have a line that's falling down from left to right. Now, what we're going to do next here to plot the second point is we're going to use the slope to help us plot that second point. So what I'm going to do here is I'm going to take this -4/3 and break it down for you. All right. So what do these two numbers mean? Now remember that when you're looking at the slope of the line, the top number represents the rise, and the bottom number represents the run. So this -4 over here, okay, is the rise. But if you think about a negative rise, what does that really mean? Well, it means that you'll be going downwards. So when you have a negative rise here from this point of 2, 8, you're going to go down 4. So I want you to see exactly what that -4 represents. All right, so you're going to see that when we draw the line here. Now, after we go down 4, you notice the run here is 3, okay, and it's positive. Okay, now just for simplicity over here, for all the examples, always treat the run as a positive and whenever you have a negative slope. That's why I always remind my students to put the negative on the numerator or the top number there. All right, so that run of 3 will tell me that I'm going to go down 3. Now, what I'm going to do for this next step here is I'm going to use guidelines, and I'll tell you exactly what you need to draw here. As I said before, we're going to use these numbers to plot the second point. So if you take a look at this 2, 8 where my cursor is, okay, from that 2, 8, we're going to go down 4 and then right 3, as you can see. Now, you do not need to draw those red dotted lines because those are just guidelines, okay? So this red line going from this point downwards, okay, that's going to give me a rise of -4 or down 4. So I'm going to go down 4 and then right 3. And last but not least, for step number 3 over here, we plot our point. Okay, and when we plot our point over here, don't forget you can connect those 2 points there with a straight line. Okay, and in this case over here, what we have here are the coordinates 5 and 4. Because remember, you always have to state the x coordinate first and the y coordinate second. All right. Now, anytime you're dealing with a question like this, and you're going to see a couple in your review package there, is the fact that if you take a look at any point, always start off the rise, plotting the second point using the rise from the point that you've plotted. Okay, so just to go back to the previous, what I just did up here, I'm just doing a quick rewind. All right, so from the point I plotted, I went down 4 and then right 3. Then I plotted. Now, remember I said at the beginning of the lesson, always think about what the line should look like, and we determined that anything with a negative slope is a line that's falling down the right, and we have exactly that. Okay, so I just want to bring that to your attention, is that you can do this for any slope and for any point. All right. So again, just make sure you state a statement indicating what the other possible endpoint is. Okay, and remember that the first number is always the x coordinate and the second number is always the y coordinate. And that wraps up today's lesson over here for the calculation of the slope. So until the next lesson, Mr. Kaplan is signing out.